Okay, so hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is ugly number 2. So for using this, you should have solved ugly number 1, but if you haven't, it's not that either. So an ugly number is what? A positive integers whose prime factors are limited to 2, 3, and 5. Okay, given an integer n, return the nth ugly number. Not to tell if n is an ugly number, give the nth. So given n is 10, you have a list of the first 10 ugly numbers, and now what you have to do is just give me the last element of list, which is 12. If n is 1, there is only a single element, so return 1. Now I'll show you three approaches, right? The first one is that you cannot practically use, but because that would give you a time limit exceeded, but we'll anyways go over that. And before you switch to another video, I would request you to at least see the demonstration part or the dry run part that I would be doing in my notes. So started. So the very first approach is a brute force approach. Okay, so how do you go by this brute force? So what you'll do is you set a counter I is equal to 1, or basically a number is equal to 1, and you'll keep a count as equal to n given as in the function. Now what you do is you check if ugly. You write a function which checks this is ugly or not, and it takes an argument and returns true or false, right? So whenever you see if this number is ugly, what you do is, rather than having a counter as n, take counter as 0, and what you can do is, whenever check if ugly is check if ugly num gives you true, what you do is you do a count plus plus, and after that you know that you have seen at least 1 for num equal to 1. You know you have seen a ugly number, so you increment the count, keeps track of the number of ugly numbers you have seen till now. Now whenever count is equal to n, you return the num. So whenever you found the nth ugly number, you return this number. So how do you write check if ugly num? You basically take that number n, let's say ciu of num is what. So you check if num is equal to 1, or it's not equal to 1, and num modulo if num is not 1. So you will call this function for a number greater than equal to 1, because that is the first positive number. So you do this, and for this you just, rather than if, you do this while num is not equal to 1 and num modulo 5 is 0, you just divide this, right, till the time it is divisible by 5. Keep on dividing it, and similarly what you do is you do the same thing 3, and similarly with 2 as well. So after this, if, or basically return num equal to 1. So let's say if you're divisible by 5, 3 and 2, after repeated division, in the end you would be remaining with, you would have basically num is 0. If that is not the case, if num is not 1, then you have prime factor other than 5, 3 and 2. So in that case, num is not 1, return false. Otherwise, if num is 1, you have an ugly number and you take that as a part of your count. So this is the whole function. Okay, so let's look at the code exactly. So what this is given as, if m is not equal to 1 and m modulo 5 is 0, then you just divide that 5, because that number is divisible by 5, and you do that till the time you extract all the prime factor 5 from this m. And you do this for 3 and you do this for 2 as well, and in the end, if m is actually 1, you return true, otherwise you return false. So this is what you will be getting as an ugly number. If you see, I just ran that code, and problem with this, the runtime, it's taking too much. This is working, this is logical, the brute force, but is, you see the case of this 1407, you have such a big number, so you would have divided or checked every number before this number, that is it an ugly number or not. So you would have more false cases and true cases. So this is not a good approach. This is at least a way you would have been able to solve this. Now the next approach is something that was not the first. So this idea is the first one that I got. The brute force was the second idea that I thought of. So the next way is using something like a breadth first search or a Dijkstra's algorithm, something similar to that. Now what I do is, let's again look at the notebook and see what I'm trying to do. So second approach, so we will look at a tree. So what this tree is doing is, what is the first ugly number? It's right, it's 1. What are the possible next ugly numbers? So I'll say it's either 2, it's either 3, or it's either 5 because into 2 into 3 2. Now what could be the next possible 3? What do I say? If you increase the branch, you'll 4, you'll get 6, and you'll get 10. Similarly, you multiply this 3 with 2, 3, and 5, so 9, and you'll get 15. And similarly, you'll get 10, you'll get 15, and you'll get, so these are, so basically all these numbers that you see are the ugly numbers. And using this logic, you can basically generate all the possible cases. At every node it will be branching out to 3, and you would be good. Now what is logic? What I'll be using is a priority queue, or which is known as the basically heap. So I'll be using the min heap. Now let's say we have to find the 10th ugly number, right? Or let's say we use a more simpler approach. We'll use the ugly number. We need to find this using this. So now what I will do, I'll not show you the exact code, I'll show you the log. So let's say this is my priority queue. Now what I do is, since I know that 1 is my, what do I say, 1 is a ugly number, I just push 1, and what I'll say is pop this out and find all the from this node. Either you could have what, you could have 2 if you multiply this by 2, you could have 3, you could have this if you multiply it by 3, and if you multiply it by 5 you would have 2, 3, and so now what you do is you also take a list, array, set, hash set, whatever you want. You take some to keep track of visitedness, and so since the numbers could be very huge, so we would, at least I would be using a set data structure. Keep track, if I've seen this track of a million digits, that would only contain about 1,000 ugly numbers, so we'd be using a lot of space that is not actually required. So since I took this one out, let's write this here. What I see is I'll mark set, or I'll mark visited set as, let's say we have 1. Now what I do is I see the neighbors or the children of this node 2, 3, and 5, and I'll just push that in the priority queue if they are not visited. So now what I do is 2, 3, and 5. Now we are done with this, so let's remove this. Now since this is a min heap, now what I would do is take out the minimum element from this, and I'll just remove that from the stack, sorry, priority queue. And now we have a node 2. What are the possible children? We could have 4 by multiplying it by 2, we could have 6 by multiplying by it by 3, we could have 10 by multiplying it by 5. So before that we should mark 2, 3, and 5. What do I see? I see that, right, so I have value of 4, I have value of 6, value of 10. Neither of them are visited, so I'll just push that into my queue, 4, 6, and 10. Now I'll basically, so whenever I do the popping, right, I'll do a count plus plus, keep track of which I mean to say which ugly number we are currently at. So since we had 1 popped out, we had 2 popped out, so count is 2. Now we push the neighbors 4, 6, and 10. We mark them as visited, 4, 6, and 10. Now what we do is just take these out, just remove this as well. Now after that, since I'm done with 2, I'll take out 3, I'll push all the neighbors, so my count is to 3, push out 4, add the neighbors, increase the count to 4, then take out the next element which will be 5, take out 5, add all the adjacent nodes, you make this count. Now since we needed to find the 5th ugly number, so whenever the count reaches n, which is the number of nth ugly number that we had to find, we just return this value. So basically this is using a graph approach. What you would be doing is going here, you will be pushing all the adjacent nodes if they are not visited, keep doing it till the time you are at a node that is the 5th. When you pop out the nth ugly number, you return that as the answer. You keep track of how many nodes you popped. So let's look at the implementation. So I just used a priority queue. I just declared it as long because it was giving me some error, right? So I take that count as 1 and I push 1 because 1 is an ugly number that I know of. Now I take this multiplier array which allows me to do the multiplication and pushing in a for loop, and take a set. Now while true, because at some point the numbers n are infinite, are infinite ugly numbers, so we could n as max as you want. But what I would do is just I'll take a while true loop and return the answer from the inside. Since we won't be getting out of this while loop, this return would never be executed. Now while true, I take out the topmost element in the queue, I pop that from the queue, or basically whenever I say queue, replace priority queue. If count is n, I just return the top value because I have popped n elements, that means that is the nth ugly number. Now I increase the count. This is not n, I increase the count, and for all the edges I calculate what are the edges, which is this top, and basically the multiplier, which is a 2 3. So you multiply that, so you get the children, and you try to find that in your set data structure. And if you did not find it, so that means this is a new ugly number that you were able to find. You push that to your priority queue or your min heap, and you mark that as. Once you're done with that, you just for the next item until the time you pop out the first n elements of this priority queue. You just go on doing this. When you are at count is equal to n, you return what is the nth ugly number. This is the more logical approach that I thought, or the first solution that I. Now the most important is the most optimized, and this would take some time for you to understand, but in that we would be using an array, and for that you have to look at this hint 3 and hint 4 to keep an idea of what you could actually do. Now let's finally look at the, I think, optimized or the most optimized one in my 3 answers. So you need nth, right? You need the nth ugly number. So what I do is I declare an array size n, and now you have to actually to understand this better. No one can just explain you and you would be able to understand. It's not like that. I can show you the dry run for you to understand. I really want you to do the dry run so that you would actually get the idea. So what is the first ugly number, which is 1? Declared it like that. Now I'll have 3 pointers to this. Let's mark this arrow and label this as 2, 3 and 5. This is easier to keep track of. Now what I do is I check the following, and also we would have an iterator as I, right, to travel throughout the list. So what I would do is, so first of all what I would do, 3 iterators, 2, 3 and 5. In terms of programming, I'll refer to them as iterator 2, iterator 3 and iterator 5. And since this is the first ugly number, what you would do is take nums. So everything is initially pointing to the 0th index, right? So what you'll do is check nums of i2 times 2, nums of i3 times 3, nums of i5 times 5, and you find whichever is the minimum, right? After you find this, the minimum to that, what you'll do is you'll place that value at this location. So let's look at the, for this case, look at what are the values. Nums of i2 times 2 is 2, nums of i3 times 3, nums of i5 times 5 is basically 5. So what is the minimum? That is 2. So what I'll do is I'll take this I'll place it here, I, and take the minimum element and place it. So the minimum element is, it's 2. So we have the, now after doing this, since we have considered 2, I'll just change the iterator of 2 to the next ugly number. So basically i2 plus plus. So I'll take this 2 here and I'll place this. Now I'll do the same. I'll find the values. So nums of i2 times 2 is 4, nums of i3 times 3 is 3, nums of i5 times 5 is, now what is the minimum element from this is this one. So what I do, I take this I'll place this here and take this 3, place this here, and since I've used, to get this value, I've used i3, right? So I'll change the i3 to the next ugly number. I'll do this. So let's calculate. So since i3 is the only one that is updated, so i3 is now i3 6. Now what is the minimum value of these 3, right? What is the minimum? It's 4, right? So I was here, so I'll take this I from here, place I here, and whichever is the minimum, I place the value here, and I came here through this i2, right? So I'll take this i2 and I'll move it one step to the right. Fine. Now what is the updated? Now if we had to update this, so we updated 4, right? 4 won't be in my new thing. This i2 is now updated to its 3rd index. So nums of i2 is what? 3 times 2 is, when 3 times 2 is 6. Now we need to decide what we have to do when we duplicate elements. But before that, we don't have the duplicate elements as the minimum element. We have 5 as our minimum element. So what I'll do is I'll take this I, move it one place to the right, mark this 5, and move the iterator 5 one step towards the, or to the next ugly number. Okay, now you're done with this. Now the minimum thing that we're trying to find, this won't be there. So now 5 is pointing to a value 2. So 2 times 5 would be 10. So now what, you have 2 minimum elements, right? So either you can just take one, say we take this value and we won't do anything with i3. So let's hypothetically do that, and we'll see what the problem. I'll take this I, I'll place it here, I, take the minimum element, this one, and place it this I. Now since this is true, what I would do is I would remove this. I2 would be shifted right. So since I2 would be shifted one place towards the right, and we have a value of 4, so it would be, this value would be what? This value would be 8, and 2 is pointing. Now when you find the minimum element, again you would find, and according to the rules, you would again place the value 6 here, you place this I here, right? And in that case you would be having duplicate elements which you don't want, right? You want the nth, you want your nth ugly number to be stored at this position. You don't want repeated elements. So what you do is, so when, let's move a step back, and you found this, you were at this position and this was not there, I was pointing here. So when we do this, when we find duplicate elements, right, we update the iterators of both the elements which are contributing to this. So basically what happen, it will take these two elements and you'll move both of them towards the right, and yep, before that you'll add value 6 here and your I would be updated here. Now if you calculate this, right, two elements would be now updated. So in this min, so I2 times 2 is 8 and I3 times 3 is 9, 3 but 9. So clearly now you have your next element as 8, the number, place the value of 8, and you'll do this algorithm till the time you reach, and at the end whatever the last element would be is your nth ugly number. Hope you got at least some idea. When you look at the code and you'll do the dry run of the for yourself, let's say for the two test cases that you're given, try to do this dry run. Once you do that, you'll get a clear idea what you're trying to do. So now let's look at how do you actually implement that. Okay, so here it is. So we have three iterators, I2, I3 and I5, and the initial answer, the first ugly number is 1. So I mark that as 1, assuming n is always greater than 1, right? Constraint is given, so I do not have to check for n is equal to 0. So yep, we have this as 1. So if the size of n is 0, this would cause an error. So we have three iterators, I2, I3 and I5, and since I've done for the first element, I've manually written the first case. So I start from I equal to 1. Now what I do is find the minimum element of array of I2 times 2, array of I3 times 3, and array of I5 minus I5 times 5 minus. Now that would be the my answer of. Now what I would do is I would check this answer came from this answer 2 or answer 3 or answer 5. You increment that pointer by 1 to go to the next ugly number, right? So what would happen is you would have, so once when we talked about duplicates, if you had two numbers, right, contributing to the same answer, right, so you'll increment both I2 and I3 well as in our dry run, right? So that is why it's not else if but just 3 if statement. Now how do we know that duplicates when they would come together, right? Let's say in iteration 1 we got 6 and in iteration 2 we again got 6, right? How do we know they are not from different iterations? So for that I'll just explain that after this code explanation, but just assume whenever you see duplicates you'll see them together. So in the end you do this till you reach the last element, and after you reach the last element you return is the lastmost number, answer dot back. That means the last element of the array, and this is like very optimized approach. It is a linear time solution and a linear space solution. So in this case, because the brute force was horrible, the priority to queue could take login to push, right? Login to push and pop, and yep, this is too much. Something the time and space complexity is similar to Dijkstra's, something like that. 3 edges, you have a visited push, right? But you don't know the size of the graph, how long you would have to. But this is a linear time solution, right? Minus one is a linear time and linear space, and that is what we are returning back. Now let's see again in the notebook that why, if the duplicates would occur, they would occur together. So you saw that we got 6 and 6 together, right? 6 and 6 together. So why was the case like this? So if you see, we are already having all these elements in a sorted order, and so no number in this equal to the number behind this. So if let's say 6 occurred here, and let's say at iteration, say 10th iteration, you won't find a 6 again, because the elements are always placed in the array in sorted order. If you had found a 6, would be at this position itself, because the array is sorted. That's the only explanation. Because hypothetically at this point you are finding a 6, that means that means you did something wrong along the, either the code is wrong or something else is wrong. If you find 6, you'll have it exactly at this, or you won't have it at all, since you would have it At this position, you would have multiple elements at max during the same time. So that is the whole idea. Hope that was clear. And yep, it's a pretty long video with basically three approaches: the brute force, the graph search, the priority queue search, and the linear time optimized solution. Hope this was clear to you. Hope this was helpful. And yep, thanks for watching, and I'll see you in the next video.